Hello everyone, this is Mohammed again, and this is another video on the STM Nucleo tutorial series. And at this video, I want to show you how to use I2C on the Nucleo. This video is meant to be for people who have not used I2C on the STM board before and want to know the basics of setting up a slave address, transmitting and receiving data via I2C. So before we begin, let me give you a very brief introduction to I2C that might come useful. So I2C has got two lines, data and clock line, and you connect the master and all the other slaves in parallel to these two lines. You can have many slaves as long as each of them has got a unique slave address. And in my demo today, I'm going to be using this DS1307 real-time clock as my slave I2C device. So you need to connect the serial clock to the serial clock of the STM, data to the data of the STM, VCC to 3.3 volt, ground to ground. Okay. So I'm going to be using this device to show you how to write and read data from the internal registers. So let's go to CubeMX and set up a new project. And on here, first click on New Project, and we need to select the right board. So go to Board Selector, it's a Nucleo 64 pins board, of 4 MCU, and it's the F401RE. This is the board default pinout. Has got couple pins fully enabled and some other pins partially enabled. So what I'll do first is I'll clear all the pinouts and I will enable them manually. So clear pinout, and I'll enable the LED on the board, GPIO output, and now I need to enable my I2C lines. And the I2C lines, according to the pinout, are on PP8 and PP9. So if you look at the picture of the board, you can see on the Arduino connector, serial clock and serial data are on here, which are connected to these bottom pins, which are PP8 and PP9. So PP8 is the serial clock, so right on this, I2C1 serial clock, and PP9 is serial data. And you can see them partially enabled, so what I'll need to do is I need to go to I2C1 and enable it as an I2C. And now they're fully enabled. And that's all I need on the pinout. So now let's go to configuration and see if there is anything we can change on the I2C config. But I don't think I'll change anything. I'll leave everything as default and click OK. Now we're ready to generate the source code. So click on Generate Source Code icon. Give the project a name. I'm going to call it I2C video. Select a location to store your files in and your IDE, which is MDK ARM v5, and click OK. And once the source code is generated, click on Open Project, and this will take you straight to your IDE. And on Keil, expand this project folder, Application User, and open the main. The first thing we're going to do here is that we're going to check the device, if the communication is correct or if the slave address is correct. There's a function specifically for that. If you go under Functions tab and I2C.c, function called isDeviceReady, and this function checks the I2C slave address and also the physical communication. If they're successful, then this function will proceed and return health status OK. So the first parameter this function takes is the I2C handle tab diff. It is hi2c1, and then the slave address. Well, the slave address according to the datasheet of the device is 1101000. Now on an Arduino, the address will come 6, 8 in hex, but on the STM board it also includes the read-write bit. So on the STM this will read D0 in hex. So the address is 0xD0, and we're going to verify this here. The next parameter is the number of trials. This will try to connect to the device, maybe 2. The timeout 10 milliseconds should be enough. Now I'm going to put an if condition. If this is successful, if this returned hello OK, then I'm going to toggle my LED. And I know my LED is on port A pin 5, so I'm going to use the hello toggle function. So just like that. So let's compile the code first. Okay, compiled successfully without any errors. Now let's load it to the board, and we're going to have a look at the board. If the LED toggled on, then the slave address is correct and the communication is set up. Okay, very good. The LED toggled on, which means our slave address is correct and our wiring are correct too. So just to test, I'm going to change the slave address to anything like 32, whatever, and I want to test again. Just want to verify that now I don't expect the LED to come on because the slave address will be wrong. So let me just verify for that quick. Okay, good. The LED didn't come on, so the function works okay. Now, let me show you how to transmit data via I2C. And just by writing to the registers, I want to write to the seconds register to enable the real-time clock. According to the datasheet, CH bit 7 and register 00 is the clock halt, and this one is set to 1 by default after reset. And if we bring this one low, the real-time clock will kick in and it will start working. So I'm just going to write 0 to register 00. And after that we will test the read function by reading the seconds. So now to transmit, we use this function, HAL I2C master transmit, this one. So and this function takes many parameters. The first one is the I2C handle tab diff, so HI2C 1, and the second parameter is the data buffer. So I need to define a data buffer to store the I2C data as an unsigned 8-bit perhaps array of two elements would be more than enough, and I'll use this to send the command and data. So now here all I need to do is to in the first location I'm gonna store the register that I want to write to, and on the second one the data that I want to write to, and the data will be anything as long as bit 7 is cleared. So perhaps 7F, this will be enough because the register suggests that if this one is low, it doesn't matter what you put the seconds are. If this one is low, then the real-time clock will kick in and start. So I'm just going to send 7F, and then you pass this as a parameter to the function. And the next parameter a function expects is the size of the data you want to send. No, sorry, we skipped one of them. The second parameter is meant to be the slave address, which is D0. And then this is correct, the data buffer and the size. We are sending 2 bytes, the register address followed by the data to be written to that register. Next parameter is just the timeout, so 10 milliseconds will do it. Okay, so this should start the timer, and to verify that this worked, let's do receive function or read. And to read via I2C, we use exactly the same principle, except we don't transmit 2 bytes one after the other. We first transmit the register address and then followed by a receive function. So here's how we're going to do it. So you first transmit the register address only, not followed by data, just to open communication to that address. So we're only sending a single byte, which is just the register address, and then followed by a receive operation. So we need to use I2C master receive function. And the receive function takes similar parameters, except the data buffer is the buffer in which data will be returned in. So I want my received data to be stored in the first location in the array, in index 1, not index 0. So I need to put a pointer to that, and I'm receiving only 1 byte. So what this function would do is that I transmit the register to open communication to that register address, register 00, and this would read the seconds data. So it will read the seconds. And let me do this in the while loop so that I continuously acquire seconds data. And I will put a delay of perhaps just a little delay of 30 milliseconds perhaps will do me enough. So let's compile the code, load it to the board, and we're going to test this in debugging mode. Okay, compiled successfully without any errors. Now loading it to the board. And let's get into debugging mode. On debugging mode, the first thing we need to do is to add this variable to the watch memory so that we'll be able to see the return data. And we expect the return data to be returned to the second position, index number 1 in the array. So I expect this one to update regularly. So now let's run the code. Alright, really good. I can already see this being updated. So this one changes continuously. This is the seconds data. really good. Okay, so this should be enough to start you up. I've shown you today how to check for the I2C communication and I2C slave address using the sDeviceReady function, and I've shown you how to transmit and receive data via I2C. So that's all for today, and as always, if you found this video helpful and want to see more videos like this in future, don't forget to like and subscribe. Thanks, and I'll see you next time. Bye bye.